Welcome to the Future of Environment demonstration at the AWS Summit Australia and New Zealand 2022. I'm really excited to show you what we have built here today, and a quick shout out to my colleagues Ben, Miranda and Rory, who have worked alongside me on the build. In this demonstration, we are going to be deploying a variety of environmental monitoring sensors into our scaled farm environment. We're going to leverage the AWS IoT Core for Lorawan service to collect our sensor data. Then finally, we will process the sensor data on AWS using a serverless architecture and visualize the results in a real-time dashboard. We have two main learning objectives for this demonstration. One, understand what Lorawan is and when you might use it in an IoT solution. And two, understand how AWS IoT Core for Lorawan has made deploying a Lorawan-based solution easier. The key theme in this demonstration, though, is how we can help the world to improve environmental outcomes. Large parts of the world's farmland, oceans, forests and national parks are in decline, and we need to make data-driven decisions about how to halt and then reverse this trend. Deploying IoT environmental monitoring solutions will be an important part in giving us the data we need to make these decisions and to verify that any changes we make are having the intended effect. As you will see in the following slides, Lorawan is an IoT communications technology that is particularly well suited to the task of environmental monitoring. One of the main challenges in environmental monitoring is the distances over which you need to collect data. In this diagram, we have two sensors deployed, a soil moisture sensor and a water level sensor that may be positioned up to 10 kilometres from the nearest man-made structure. What are our options for collecting our sensor data and shipping it to the AWS cloud for processing? The first option to look at is using satellites. The great thing about this solution is that there is comprehensive coverage over most parts of Australia and New Zealand. The downside to deploying a sensor that is capable of communicating directly with a satellite is that the individual device cost and the power requirements are higher than other options. If you're looking to blanket a farm in hundreds of sensors, then it will be hard to do this economically solely using satellite. The next option to consider is using the 4G, 5G networks. The main drawback to this approach is that for parts of Australia and New Zealand's farmlands and national parks, it is uneconomical to provide 4G, 5G network coverage. You may find that parts of your farm have network coverage and some parts don't. The final option that we will talk about today, and the one that is the focus of our demo, is LoRaWAN. LoRa stands for long range and is a method for transmitting data using radio signals. LoRaWAN is then a specification for a low power, wide area network that uses LoRa as the communication technology and is designed specifically to connect with battery-operated sensors. A farmer can build their own LoRaWAN network with the installation of a Lorawan Gateway and a radio antenna from as little as $800 Australian. Once you have a LoRaWAN network set up, you can start adding LoRaWAN-based sensors within a 10-kilometre radius with a line of sight of the radio antenna. These sensors are relatively low cost, starting at $100 Australian, run on battery power, and can be left in the field for up to 3 to 5 years. The main drawback to LoRaWAN is that it doesn't support high bandwidth use cases. You can't stream video over LoRaWAN, as an example. A lot of environmental monitoring use cases, though, do not need a lot of bandwidth. A soil moisture sensor, as an example, if it wakes up once every 3 hours, sends an observation on soil moisture levels, may only be sending a few kilobytes of data a day. As a more concrete example, I set up a Lorawan IoT solution on my family farm last year. With the installation of a $600 Lorawan Gateway and a $150 fiberglass antenna at the main house in the middle of the property, we were able to achieve full farm network coverage and install a number of low-cost sensors. Let's now take a look at the sensors we have deployed on set. In the middle of the console here, we have our Lorawan Gateway. Its job is to receive radio transmissions from our Lorawan sensors and deliver the digitized results over an internet connection to AWS. AWS IoT Core for Lorawan provides a workflow for generating a set of endpoints and certificates that you install on the gateway to connect it securely with your AWS account. If you're looking to buy a Lorawan Gateway, you can have a look at the AWS Device Partner Catalog, which has a list of gateways that have been certified to run on AWS IoT Core for Lorawan. Let's have a quick look at a Lorawan sensor. These vary a lot in shape and size, but common elements include the electronics for sending radio transmissions, a lithium battery, and an attached or integrated sensor. AWS IoT Core for Lorawan provides a workflow for registering your sensors so that transmissions can be securely processed by your gateway. Now let's have a look at the AWS architecture we are using to process our sensor data. Starting on the left-hand side, data travels from the sensor to the physical gateway and into the AWS IoT Core service in your AWS account. At this point, you're free to use any of AWS's data and analytics services to process your data, but as a point of reference, we have opted for the following architecture. First, we log the raw messages into CloudWatch logs, so we have a copy for debugging purposes. Then, because Lorawan sensors generally look to minimize bandwidth usage by using binary data protocols, we need to run a decoder function to translate our message into a format we can reason about. After this, we again push our decoded message into CloudWatch logs. And then a nice option at this point is to use Amazon Managed Grafana to visualize the data directly from CloudWatch logs. For our demo today, though, we have chosen to take this one step further with a digital twin of our set here today. My colleague Ben has built us a 3D model of the demo set we have today to help us better relate to the sensor data being collected. Elements in the model change based on the state of our sensors, based on the state that our sensors are reporting. You will see some time series graphs above our set to better understand the historical trends of these sensors. Now let's take a look at some of the sensors we have deployed here on set. The first sensor we have on the left-hand side of our set detects when a gate is opened or closed. Rory, would you mind opening the gate for us, please? On-farm biosecurity plans and procedures is one area where farmers are looking to improve management practices. Knowing if gates have been left open can be an important tool in preventing contamination risks from off-farm or from adjacent fields. We can now see on the dashboard that the gate is being, as it's showing, is open. Cool. In this next example, we have an example of a more powerful device, capable of running a machine learning model for image classification that leverages the Lorawan network for sending alerts. Ben, would you like to introduce our Fox to the set, please? My colleague Ben has trained an image classification model in AWS SageMaker that is capable of identifying if there is a fox present in our camera's video feed. Introduced pets such as foxes, wild cats and wild dogs have a large economic and ecological impact on the Australian agricultural industry. And any improved monitoring we can introduce to help manage this problem will be well received. Looking at the dashboard, we can now see that our alert for a fox in the paddock has come through. The final sensor we wanted to highlight today is the light level sensor deployed in our veggie patch. Miranda, can you please simulate a low light situation? Understanding if our plants are receiving a sufficient amount of light for optimal growing conditions is a useful data point in both a field or a greenhouse situation. In a more controlled environment like a greenhouse, you may use this real-time information to trigger growing lights to come on, as we have done here on set. You can now see in both the veggie patch and on our dashboard that the lights have come on. In addition to the sensors we have just highlighted, we have a number of other sensors deployed on set, including a temperature and humidity sensor, a soil moisture sensor in our veggie patch, and a water level sensor on the water tank behind me. Let's jump back to the slides to have a look at the costs involved in setting up our demo today. Earlier, I mentioned that setting up a private LoRaWAN network could be done cost effectively. As a point of reference, the cost of what we have built here today is enumerated on this slide. Setting up the LoRaWAN network cost us $600, and then each of our sensors were around 150 Australian dollars. The other area where you incur costs is in processing and visualizing your data. If you are adopting a serverless architecture, similar to the one we have leveraged in this demonstration, then you can get a long way with the AWS free tier. Given we were processing less than 20 sensors worth of data, we were staying under the caps for the AWS free tier for most of the services used. In summary, we think that LoRaWAN supported by the AWS IoT Core for LoRaWAN service is a useful addition to your IoT solutions kit bag. In particular, the strengths of LoRaWAN make it particularly well suited to environmental monitoring use cases, and there is still a lot of unrealized potential for this technology to help us have a positive impact on the environment. We encourage you to have a go at setting up your own LoRaWAN network and have fun experimenting with the growing number of LoRaWAN sensors that are available on the market. If you can help to have a positive impact on the environment, then that's even better. It's been a great experience getting to share this demo with you today. And on behalf of Ben, Miranda, Rory, and myself, thanks for your time today.
Hi everyone, and thanks for tuning in. As the world fast approaches 2025, 2040 and beyond, sustainability is becoming an economic business imperative. Financial services industries are leading the way, actually, and this is going to shape how businesses are funded into the future. I'm Luke Hargreaves, and this is the future of sustainability. Now, this is an AWS conference, and IT has a clear role to play. So let's talk about the brave new world of clean technology. If we consider sustainability to be the ability of today's generation to meet the needs of next generation, including the three pillars, which is environmental, social, and governance, then what does that mean for IT? It means that we as technologists have a responsibility to build our projects with the smallest carbon footprint possible and in a responsible way. So according to a 2021 Reuters report, the world emitted 36.4 billion metric tons of carbon, or CO2e we call it, equivalents, just in the year of 2021. Now, when you consider that ANZ emits 1.25% of that, and if we further reduce that to just from the IT industry, that amounts to 9 megatons of CO2 equivalents just from Australia and New Zealand's IT industry. Now, if we plug that into an EPA calculator, what you'll see is that that equates to about 3 million tons of waste, or, and I really like this one, 3.4 billion litres of gasoline. Yes, billion litres of gasoline. So to use an Australian euphemism, we need to clean up our own backyard. Right, so drawing on both internal practices and customer feedback, as we do at AWS, we describe the carbon reduction journey as having 3 phases: migration, optimization, and transformation. Now, I won't make you wait. Actually, I will make you wait as I walk across to this server room here. But according to a 451 independent report, if you migrate or do a standard migration to AWS direct from where you are right now into the cloud, no optimizations, you're immediately saving 80% carbon. And that's not a typo. That's 80% carbon. Right? So if we do work backwards into this, as we do at Amazon, there are 3 main factors involved. There's energy mix, power usage effectiveness, and density. And I'm just going to quickly go into each of those. Energy mix, number 1, talks about how carbon intensive the energy is. So whether it comes from renewable sources or whether it comes from a carbon or fossil fuel source. Power usage effectiveness is a ratio. So it's the amount of energy that goes into your data center that goes direct to compute workloads, not necessarily to like air conditioning or, server function or something like that. And the third one is density. So we've been doing this since 2006. We have a really sophisticated set of placement models to the point where we're able to where we're able to use up to 60% capacity. And I'll show you how that works in a second. So by using cleaner energy, directing to more compute workloads and running an average 60% capacity as opposed to 20 in a standard data center, you're now running 5 times more efficient, which is where we get the 80% from. Now, this is a demo, and so I wanted to cut right now to the AWS Customer Carbon Calculator. Up in the top right-hand corner, and this is really critical here, you can see your baseline metrics. It's been so hard traditionally to get any baseline metrics, so what you've got here is a starting point. And a lot of the time, that's all we need. Draw a line in the sand, you've got a starting point. But crucially, just from this migration as well, you are now emitting only 1/5 of the carbon that you did. And you're saving money. I'll just ask Qantas about that, but more on that in a little bit later. Right, I'm going to walk over this way. So you've made the jump and migrated your workloads to AWS. So as Han Solo and Anakin, I think, said, this is where the fun begins. Now it's time to optimize. So in November 2021, as part of our yearly reInvent conference, AWS announced the long-awaited 6th pillar in the well-architected framework. We already had the operational excellence, security, reliability, performance efficiency, and cost optimization pillars. Sustainability augments that and gives prescriptive guidance on how to optimize your landscape, IT landscape, for sustainability. It's broken into 5 sections: users, software, data, hardware, and deployment. And what I thought I'd do is I'd just take one of these sections. So let's take deployment and apply it to a real-life workload. Machine learning and encryption are 2 of the highest emitters, so let's take a machine learning example. And recent research from the University of Massachusetts by Emma Strobel has shown that training a single NLP model can have the equivalent carbon footprint of up to 125 return flights from Beijing to New York, which is crazy, right? Just a single NLP model. Now, there are 2 main factors to a machine learning model. The first one is software, and the second one is hardware. Now, I have a whole series dedicated to software. But what I wanted to do was to focus here on the hardware section for the purposes of this demo, particularly around the deployment of your hardware as just one thing that we can optimize from a sustainability point of view. So one of the largest impacts you can immediately make is to have a look at the regions you're deploying your dev and test workloads into. So if you deploy to a region such as Oregon, Frankfurt, Ireland, Canada, or even US Gulf Cloud, you're immediately reducing your carbon footprint by an order of magnitude. So this is the idea of using the global nature of AWS for a sustainable purpose. Okay? Right. So we have this demo. This is the second part of it. What I wanted to show you as part of the carbon calculator here is the central part up in the top. So you can see that big pink circle. That's showing you that all your resources are running in America at the moment. Now, there are 2 other regions, obviously EMEA and APAC. When you run workloads in different regions, they will show up in this circle. Also, you have a set of services that you can use. And you can see EC2 there as a pulled out service directly. Now, our Graviton instances run at 60% less, use 60% less energy and can actually be up to 40% cheaper. So I like to talk around economics. You'll notice that this will be a continuous theme in sustainability. But above all, and I can't stress this enough, only deploy workloads that you need to deploy. Don't run things you don't need to. As we like to say, the greenest energy is the energy we don't use. So by being extremely conservative, let's assume you can achieve even a modest reduction of around 33%. This further reduces your reportable carbon footprint, a footprint that will magically start to shrink in the background. We're up to the second part now. So using the cloud for new and innovative climate-related solutions has a multiplying effect. And in many ways, the culmination of this journey, which is transformation. However, before we get into how that works, something's happening in the background that we need to look at. Do you see the graph at the bottom there? That's the path to net carbon zero. Okay? Now, as you can imagine, 100% renewable energy plays a big role in net carbon zero for IT. That graph plots a path to 2025. In AWS, we have a goal of being 100% renewable by 2025. Now, what else is happening here? How is this actually happening in the background? By using AWS, you not only have access to the broadest and deepest cloud technology set, but you also have inherited our sustainability goals. We call this inheritance the sustainability shared responsibility model. To hammer the point home, the bottom part in green is the migration part. The top part in blue is the optimization part. So hopefully that makes sense and brings it all around to you. But it also means that some of your goals can now reflect ours. You want your IT to be on a path to 100% renewables by 2025? That's our goal. So on Amazon, we're the world's largest corporate buyer of renewable energy. We've got 310 projects across 19 countries, totaling 15.7 gigawatts of renewable energy capacity. Currently, we're at 65%. Want to hit net zero by 2040? 10 years ahead of the Paris Agreement. Work together with us on the climate pledge. With 314 signatories, including Maersk, SAP, Coca-Cola, Microsoft, and Canva, you're in good company. So offloading these programs of work will free up critical resources that can now be repurposed on game-changing innovations that can shape the future of the industry that you're in. Which brings us into transformation. Your journey's well underway, and you now have these aforementioned resources ready to go. What now should you work on? Well, that's up to you. The world's your sustainable oyster, but I'll try to give you a little gentle nudge here. Before joining AWS as a solutions architect, I was working with the United Nations to help educate local Australian entities about the UN Sustainable Development Goals. And still, after all that, the best advice I can give you is to stick with what you know. So are you in retail? Look at supply chain optimization. In manufacturing, look at smart factories using IoT. Do you work in the energy sector? Look at demand forecasting and machine learning. However, nothing clears things up like a good old-fashioned customer examples, so here are three. First one, Qantas, obviously. No, I didn't forget to come back to this one. Qantas's Constellation system simulates thousands of possible flight paths based on millions of data points, including weather and wind patterns. This saves Qantas $40 million each year, but it also crucially saves 50,000 tonnes of CO2 emissions per year. That's a great example of how economics and sustainability fit together. The second example is the Australian Institute of Marine Science. Their Reef Cloud project scans 700 to 800 images of coral reefs and is able to tag these with 90% accuracy. So this saves a lot of time where manual tagging was originally required. This is using machine learning running on AWS. And the third example is our own Vector Energy. AWS has entered a partnership with Vector Energy for the next few years and to develop what we call the new energy platform. Now, Vector Energy is using small IoT devices to get very specific readouts of the energy grid in New Zealand. What that means is you know where your energy is coming from and you know it at a very granular level, which is fantastic. It's really, really humbling to see what our customers are doing in this space, and it's one of the great things that I get as being part of the sustainability space in AWS. I'm going to move. Right, so thankfully, now we've come full circle. However, given that this is a journey, I thought I'd visually display the carbon and reiterate the carbon reduction potential of each step that we've talked about. Okay, so let's take, for simplicity's sake, that your business emits 100 tonnes of CO2 equivalents per year. Just by moving to the cloud without any optimizations, you immediately reduce your carbon footprint by 80%. So that goes from 100 all the way down to 20. Through the use of these optimization techniques, you can conservatively, and I say that, conservatively, only 33%, reduce it a further 6% down to 14 metric tonnes of carbon per year. Also, crucially, you can further expect optimizations to be made behind the scenes because of the sustainability shared responsibility model. Analysis has shown that once we do hit 100% renewable energy across all of our operations, this baseline, instead of being 80%, can be up to 96%, which is a fantastic improvement. Right, so thank you. Please take the time to have a look at the QR code. Interestingly enough, two of our customers that I talked about, Ames and Vector, are at Summit today. So please check them out. And don't forget to check out the other sustainability related sessions, including the Ames session, and rate this demo using the QR code. Thank you very much.